Welcome. In this video, we are going to learn about how to find the inverse of the 2 by 2 matrix using the row reduction method. Now, suppose I've come across this question, which reads, find the inverse of matrix A, and this matrix A is 2, 2, -1, 4. So how can we find the inverse of this matrix using the row reduction method? We say solution. So I'll write the matrix here. I'll get this matrix, I'll write it here, which is 2, 2, -1, 4. Then here, I'll write the identity matrix, which is like that. What does it mean? This means that here, you need to form the identity matrix. Then whatever that you're going to obtain here, it is the inverse of this matrix A. How are we going to do that? Now, when you see properly, the identity matrix looks like is 1, 0, 0, 1, like that. Now, when you see properly here, there is 2. How can we form this 2 to be 1? We can only form this 2 to be 1 if we say row 1 is equals to 1 over 2 row 1. This means that the whole row is going to be divided by 1 over 2. Okay, what does it mean? We have started with row 1. This means that row 2, we are not touching it. -1, 4, 0, 1. Like this. Okay? So, 1 over 2, we are just dealing with the row 1 first. So, on the first part, there is 2, which is on row 1. So, when we put our 2 here, it will be 1 over 2, then 2 like that, which is 2 and 2. They will go, what are we going to form here? 1. How about here? Here also, when we put our 2 here, it will be 2 and 2 also, they'll go, we're going to form 1. How about here? When we put our 1 here, it will be 1 times 1, which is 1. 1 divided by 2, it will be 1 divided by 2, or 1 over 2. So we're going to have 1 over 2 here. How about here? How about here? What is the number which is there? There is 0. It is in row 1. So when we put our 0 here, it would be 1 times 0, which is 0. So it will be 0 over 2, which is just 0, like that. And now, when you see properly the identity, here, on this part, there is 0. This means that even here also, we need to form 0. But how can we form this 0? We have now started dealing with row 2. So how can we form 0 here? Using row 1. So we can only form a 0 here using row 1 if we say row 2, if you see properly this -1, it is in row 2. So row 2 is equals to row 2 plus row 1. If we add this and this, then definitely we are going to form a 0 here. So row 1 also here, it's untouchable. We are not using it. We are not dealing with row 1, but we are just using it. Okay. So this means that what is the number which is in row 2? It's -1. Plus the number which is in row 1 is 1. When we add this, we're going to have 0. This means that here we have 0. 4. What's the number which is in row 2? It is 4. Plus the number which is in row 1, it is 1. What are we going to have there? 5. So here we have 5. How about here? we are going to have, what's the number which is in row 2? It is 0 plus the number which is in row 1, it is 1 over 2, which is just saying, which is just 1 over 2. So here we have 1 over 2. Another one, what is the number which is in row 2? It is 1 plus c, which is this one, plus the number which is in row 1, it is 0, which is just 1. So here we have 1. Now, when you see properly the way our identity matrix is looking, here we have 1, but here we have 5. So even here also, we need to make a 1 here. We need to change this 5 to be 1. But how can we change this 5 to be 1? We can only do that if we say row 2 is equals to 1 over 5 row 2. So when we multiply this with 1 over 5, then definitely we are going to have a 1 here, just like the way the identity matrix is having a 1 there. So row 1, we are not touching it, like that. Okay, we are dealing with row 2. So what's the number which is on row 2? In row 2, it's 0. When we put our 0 here, this means that all of this will be 0. Okay. From there, we are here. What's the number which is in row 2? It is 5. So it will be 1 over 5, then 5 there. 5 and 5, they'll do what? They'll go. What are we going to remain with? 1. We have now formed our 1, like that. Here, it will be, I shall write our 1 over 5 there. What is the number which is in row 2? It is half, like that. So when you multiply this, it will be 1 over 10, like that. Where are we? Here, which is 1 over 5. The number which is in row 2 is what? 1. So when we multiply, we're going to have 1 over 5, like that. Okay. Now, still, we have not yet formed the identity here. So we need to form a 0 there. Now, how can we form a 0 there? We can only form a 0 there when we say row 1 is equals to row 1 minus row 2. So we need to use row 2 to form a 0 there by subtracting. We say row 1 minus row 2, like that. So here, row 2, we are not using it, which would be 1 over 5 there. Okay. So what is the number which is in row 1? There is 1. Minus. In row 2, there is what? 0. When we subtract this, we're going to have 1. Here, in row 1, we have 1 minus. In row 2, we have what? 1 there. When we subtract, we're going to have 0, like that. Here, in row 1, we have 1 over 2. Minus. In row 2, we have 1 over 10. This is a fraction. Common denominator is 10. 2 into 10 is 5. 5 times 1, 5. Minus. 10 into 10, 1. 1 times 1, 1. Which is just 4 over 5. 4 over 10. Sorry, it's 4 over 10. So 2 there, it's 2. 2 there, it is 5. So here we have 2 over 5. We are remaining with this part. Okay? So what is the number which is in row 1? It is 0. Minus the number in row 2, it is 1 over 5. 1 over 5. When we subtract this, we're going to have negative 1 over 5. Okay, so this means here we have negative 1 over 5, like that. So when we see properly, we have formed our identity, this part. This means that whatever we have obtained here, it is our inverse of A. We say, therefore, our inverse of A is equals to 2 over 5, negative 1 over 5, 1 over 10, 1 over 5, like that. So this is our inverse of A. Now, if you need to verify this, or if you want to verify this, use the secondary way of finding the inverse of the matrix. How? First find the determinant, but before that, let's try to write matrix A, which is 2, 2, -1, 4, like that. Let's try to find the determinant of this using the secondary way of finding the inverse or the determinant. What are we going to do? We multiply what's in the major diagonal. So it will be 2 times 4, which is 8. Minus, then multiply also what is in the minor diagonal, which will be -1 times 2, which will be -2. From there, when we simplify this, we are going to have 10. So this means that our determinant is 10. After that, find the adjoint of A. So how can we find the adjoint? Swap what is in the major diagonal, which will be 4, 2, like that. From there, multiply what is in the multiply a negative with what is in the minor diagonal. So when we multiply our negative there, it will be +1. There, it will be -2. So inverse. How can we find the inverse? So inverse of A is given by 1 over determinant of A, then multiplied by the adjoint of A, like that. So let me write it here. The inverse of A is equals to, what is our determinant? Our determinant is 10, like that. What is our adjoint? Our adjoint is here, which is 4, -2, 1, 2, like that. Then from there, we multiply our determinant inside the matrix. So when we multiply here, we are going to have 2 over 5, like that. When we multiply here, we are going to have -1 over 5, like that. When we multiply here, we are going to have 1 over 10. When we multiply it here, we are going to have 1 over 5. When you see properly, this is the inverse using the secondary method. And when you see properly, the numbers which are here are equal to the numbers which are there also using the row reduction method. Therefore, our inverse of matrix A is 2 over 5, -1 over 5, 1 over 10, and 1 over 5 there. Thank you for watching the video. Remember to like, share, and subscribe. Thank you very much.